Hello, everybody. Welcome to another episode of Transfigured. This episode is going to be a presentation about Jonathan Pageau and John Vervaeke's Ontology. The purpose of this presentation is to lay the groundwork for a conversation between them. And the reason for that is the upcoming midwestuary conference. So if you are unaware, the Chicagoland Bridges of Meaning group, which I host here in Chicago, is organizing the Midwestuary Festival this August 22nd through 24th in 2025. It's in Elmhurst at the Elmhurst Christian Reformed Church. We have 6 headline speakers: Paul Vanderklay, Elizabeth Oldfield, John Vervaeke, Kale Zelden, Jonathan Pageau, and Rod Dreher. You can visit midwestuary.com to buy tickets or find out more information. And Jonathan Pageau and John Vervaeke like to talk about angels and demons and gods and ontology and that sort of thing. And so because the conference theme is the fellowship of the Spirit, I thought that we should probably get a conversation out of the way about what is spirit? What is it that could be fellowshipped in? And so I was putting together this presentation, and honestly, I couldn't get it like all the size that I wanted to. So I'm going to do this in 2 parts. And so my theme for tonight, like I already mentioned, is going to be teleology and epistemology. So buckle up. The first video that I am going to play is going to be from a recent conversation between Jonathan Pageau and Mary Harrington.
People are going to do what they do, right? But one way of thinking about all of this that I found fruitful, and that I found people will respond to in quite an open way, even if they're ambivalent on some of the more sort of formally theological questions, is thinking about. Actually, this goes to your point on postmodernism, but thinking about formal and final cause. Because I mean, you can take people through the way in which the arrival into modernity was inseparable from excluding formal and final cause from the reality paradigm. I mean, first it was excluded from the scientific method. The idea that something has a form which is ordered from the top down was just excluded, and okay, now we just look at how it works and we look at it empirically, and also the idea that something has a purpose, has a telos which is intelligible to us, was also excluded from the scientific method, in favor of just looking at what's the stuff that this is made of, and what are the chains of events in which it participates, in a much more a much less richly meaningful way. And I mean, I think in more colloquial language, what we're talking about here is meaning and purpose. I think those people are perfectly, these are perfectly intelligible terms to most people. The idea that things have meaning and purpose is just not really part of the scientific paradigm, right? A chicken doesn't mean something; it's just a chicken. It's a biological system within the scientific paradigm. What's the purpose of a chicken? The purpose of a chicken is to chicken. And if you explain it to people in those terms, they're like, "Oh yeah, it's going to chicken. Chicken's going to chicken, right?" That's fine. That's like perfectly sort of self-contained, and it will do so in a set of complex relationships with various other organisms and ecosystems and so on. And people are very happy to think, are quite willing to think ecologically in that way. And then once you explain to people that there's an entire metaphysics that encompasses thinking in terms of formal and final cause, and that actually if you refactor postmodernism through that lens, it falls into place. And postmodernism isn't wrong. It's just it's just mistaken to try and do semiotics in the absence of formal and final cause. If you're only doing efficient cause and material cause, the whole thing becomes incredibly nihilistic incredibly quickly. I mean, it should be
power. It just becoms power.
Exactly. There's no meaning. There's only power. But the moment you reintroduce formal and final cause into the postmodern paradigm, it's like, oh, okay. So things can still be true. Like, so some things are more true than other things. This is clear, and some forms are more real than other forms. This is also clear. Because it's not just arbitrary and contingent and emergent from the bottom up. Whether you're talking about social systems or organisms or whatever, things are also formed, as it were, from the top down. And optionally, should you be that way inclined, you can also take that a couple of steps further, and you can reframe a discussion of the soul in those terms as really, in very much the classical sense, as the form of a person.
Mm-hmm.
This isn't crazily controversial, and it's not the homunculus piloting the meat suit. It's just, my soul is the form of me, as understood from the top down in that sense.
Yeah.
And it's the purpose of me as well. In the same way the chicken's going to chicken. Mary's going to marry because I'm ensouled as Mary, if you see what I mean. And I don't know, I feel pretty comfortable talking, people aren't going to look at me like I'm a sort of insane creature on the street if I make this, you set out the steps and people are like, oh yeah, I can go with that.
Yeah.
Or maybe not, but
no, I think you're right. What it leads to is, in some ways, that this idea of the hierarchy of goods that was,
yes.
that in the Middle Ages was, you see in Dante, that you see in Middle Age thinkers, and I think that is definitely. I mean, that's the way that I've been trying to talk about it, like to help people see that is something that is inevitable, and that these purposes, they stack too, right? They stack into each other, and so you can kind of see. You can kind of see at certain levels what the purposes are, and then you can notice that they fit into these higher purposes. And especially if you bring them through the human perspective, which is, we can't avoid it. That is, as humans, we stand here and we live in the world. You can't have a way of seeing the world that is abstracted from human consciousness. That helps too in establishing causes, like establishing formal and final causes, because in some ways you realize that there's no reason to fully abstract yourself from the system. You have to see it through this perspective. What I mean is that when you say a chicken's going to chicken, there's also the idea that the chicken is also the bird that makes eggs and that I eat, especially a chicken of all animals, because it actually now at this point has co-evolved with humans, that it couldn't exist. It couldn't exist outside of the human ecosystem. Therefore, they're part of our purposes. Like, we kind of see them through part of our purposes. And the same with even, like, the way the ancients would have understood it. It's like there are certain animals that are dangerous to us, and that has to be part of their purpose. Like, understanding that as part of their purpose. It's, there are animals that can eat you, and there are bacteria that can kill you, and that's part of at least how we kind of put the hierarchy of their purposes into the world. And what's funny about that, and I don't know if you've thought about this, but in some ways there's a sense in which if you ride the kind of Darwinian argument to its end, you almost get a return of Aristotle. You get a return of purposes. Because if you say something very simple, which is the highest purpose of life is the persistence of being, like something like that. Like at every level, right? So like the beings try to persist at every level, and that's what it is. And then you end up again with a hierarchy of purposes. You can't avoid it. You end up with a hierarchy of forms. It just almost kind of gives it, and it's, and you could say, well, those forms don't exist in a material sense, but who cares? Like and also you could say you can't find the telos from the emanation of all these possibilities, but it doesn't matter, because as conscious beings we participate in that purpose. Like we actually see them. Like we can see that eyes are for seeing. The evolutionary biologists can tell us, well, there's no purpose in evolution. It's like, yeah, but also yes, there is, because I know that eyes are for seeing.
Yeah, so that return of Neoplatonic kind of infused purpose, if you follow the thread of evolution to its logical conclusion, is something that I'm going to pick up on. So they were kind of talking about Aristotle's four causes, just to sort of refresh everybody. There's four causes in Aristotelian causation. There's the material cause, which what is something made of; the efficient cause, which is what is something, or the efficient cause, which is something like how was it made. There's the formal cause, which is what shape and structure is it. And then there's the final cause, which is why was something made. And what Jonathan and Mary's point is that science sort of hyper-focused on the material and efficient causes. What is stuff made out of and how does it move around and what causes it to move around? And it sort of needed to exclude formal cause and final cause to do its business. And this sort of led to what was originally a exclusion for the purpose of focusing on something else, kind of led in the direction of people no longer taking formal and final cause seriously, or even being suspicious of people who do. But Jonathan's point is that Darwinian theory, if you sort of think about it and follow it to its logical conclusion, sort of has to let formal and final cause back in the door in order to work. Because when you ask why is something the way it is in a Darwinian sense, you always get a why answer, not just a how or what answer. And so that this is kind of the point that they were both making. And Mary said, when you talk this way, most people on the street actually find it kind of easy. All right, so I'm going to give an example from machine learning or statistics or artificial intelligence, whatever you want to call it. All right, let's imagine that you've got a line, a very simple Cartesian line in Cartesian space. It's got a y-intercept of 2 and a slope of 1/2. Now let's randomly generate 50 data points around this line with some statistical noise. Basically, every point gets a random number added to it from a bell curve with a standard deviation of 1. And now let's remove the true answer or the real answer, the line that generated the data, and now we just have the data itself. And now let's use statistics to try and estimate or approximate what line generated this data point. And if you use statistics, you get an intercept of 2.33, a slope of 0.48, and it guesses that the standard deviation was 2. Standard deviation was 1. So you can use statistics to sort of reverse engineer the data generating function that made the line, but it will do so not quite perfectly. And so if you think about Aristotle's 4 causes in respect to this question or example, you can ask, what is it made of? And you would get something like, well, this was done with silicon, microchips, and computer hardware. If you ask the efficient cause, it's like, how is it made? Well, there's a statistical algorithm, the data, the computer, and the electricity. The formal cause, well, what shape and structure is it? And in this sort of example, there's kind of both a hard aspect and a soft aspect. The hard aspect is that my statistical algorithm already knows that it's trying to figure out a line. So it knows that it needs to be a line. And then the soft aspect is trying to estimate the parameters, the slope, the intercept, and the standard deviation. And then the final cause, why was it made? Well, it was made for me to teach you about final causation. And I think that in statistics, the way that statistics works is there's something very Plato's cavey about the whole thing. At Plato's allegory of the cave, there are people who are in a cave who have never seen real objects. They simply see the projection of them onto a cave wall. And they mistake that these objects projected onto the wall are the true objects in themselves. And then maybe in some versions of the story, they escape and realize that there are true objects and can't go back into the cave, or however you want to think about it. And statistics is often like a way of trying to reverse engineer or use induction to estimate what the true function that generated your data set was, although you often have to do this in the presence of statistical noise and insufficient information. So I'm going to read a little bit from Plato's dialogue of the Meno, which I think is also super relevant for machine learning, but it's also relevant, I think, for understanding epistemology as it relates to similarities and differences between Jonathan Pageau and Vervaeke. All right. Socrates, I perplex others, not because I am clear, but because I am utterly perplexed myself. And now I know not what virtue is, and you seem to be in the same case, although you did once perhaps know before you touched me. However, I have no objection to join with you in the inquiry. Meno, how will you look for it, Socrates, when you do not know at all what it is? How will you aim to search for something you do not know at all? If you should meet it, how will you know that this is the thing that you did not know? Socrates. I know what you mean to say, Meno. Do you realize what a debater's argument you are bringing up, that a man cannot search either for what he knows or for what he does not know? He cannot search for what he knows, since he knows it, there is no need to search, nor for what he does not know, for he does not know what to look for. As the soul is immortal, has often been born, and has seen all things here and in the underworld, there is nothing which it has not learned. So it is in no way surprising that it can recollect the things it knew before, both about virtue and other things. Nothing prevents a man, after recalling one thing only, a process men call learning, discovering everything else for himself. Meno. Yes, Socrates, but how do you mean that what we do not learn, but what we call learning is recollection? Can you teach me that this is so? Socrates. It is not easy, but I am nevertheless willing to do my best for your sake. Call one of these many slaves of yours, whichever you like, that I may prove it to you in his case. Socrates. Now, boy, do you know what a square is like this? Slave. I do. Socrates. A square is a figure where all four sides are all equal. The slave. Yes, indeed. Socrates. These lines through the middle are equal. The slave. Yes. Socrates. And I'm skipping a part of it, but you get the general idea. Socrates. You see, Meno, that I am not teaching the boy anything, but all I do is question him. Do you agree? I do. And so this is called Meno's paradox. Basically, if there is nothing in common between the learner and what is being learned, how can learning happen at all? Socrates' answer is often considered somewhat unsatisfactory, whether or not you believe in the pre-existence of souls, because it just pushes back the initial learning into the past, into previous incarnations, say, without answering how it was learned in the first place in those previous incarnations. I think Gregory of Nyssa gives a slightly more convincing answer to Meno's paradox, although it's not clear that that's what he's addressing, but I think it's relevant. For since the most beautiful and supreme good of all is the divinity itself, to which incline all things that have the desire for the beautiful, we therefore say that the intellect, as being in accordance with the image of the most beautiful, as long as it partakes so far as possible in the likeness of the archetype, also remains in the beautiful. But if it were somehow to be outside this, it will be stripped bare of the beauty in which it was. And that's Gregory of Nyssa in his book On the Human Image of God. I had a dialogue with Father John Behr, who did a translation of that recently. Check that out. Me and Hank also talked about On the Image of God. To be honest, I enjoyed my conversation with Hank more than Father John Behr. So, but I think that this dialogue by Gregory of Nyssa is honestly one of the most fascinating books from the classical world that I've ever read. But Gregory's answer seems to be something like our intellect has something in common with the beautiful because it's made after an image of the archetypal beauty, as if there is something, because we are made in the image of God, we are created sort of intrinsically with archetypal beauty and forms sort of within our intellect. And that's a different answer than sort of Socrates' reincarnation answer. All right, back to statistics for a little bit. How did I know to fit a line in the first place? So in the answer, or in the example that I made where I generated random data from a line and then fit a line to it, I knew to fit a line because I had designed the problem in the first place. But what if you don't know to fit a line, right? You see, this is kind of like Meno's paradox. If you already kind of know the answer that you're looking for, you can get your way there. But if you don't know where to start, how can you even begin to answer the question? That's sort of Meno's paradox-esque. All right. Another thing that can happen is, imagine I generate data from a curved line, right? Like here I've generated data from an exponential curve, that's the red line, and then I fit a straight line to it, that's the blue line. You can see that it kind of fits, but it actually doesn't do super well. It does a little bit better in the middle part, but it's not good on the extremes. So if there isn't a conformity between the way that the data was generated and the statistical model that you're using to fit the data, you'll get sort of a poor fit between your model and the original source of the data. All right, back to Aristotle for a bit. If thinking is like perceiving, it must be either a process in which the soul is acted upon by what is capable of being thought, or a process different from but analogous to that. The thinking part of the soul must therefore be, while impassible, capable of receiving the form of an object, that is, must be potentially identical in character with its object without being the object. Mind must be related to what is thinkable. So this is Aristotle's idea that there needs to be a conformity between what you're thinking and what you're thinking about in order for that thinking to happen. And I think that statistics example is sort of a relevant example to think about that. A little bit more Aristotle. The soul is in a way all things, for all things are either sensible or intelligible. And knowledge is in a way the object of knowledge, and sensation the object of sensation. In a sense, the soul is the form of forms. If everything is thinkable about, when we think about something, we have that form in our mind, then the mind or the soul or the intellect can be the form of all forms. Gregory of Nyssa says something similar. Thus, there is in us a form of every type of beauty, all virtue and wisdom, and every higher thing that can be conceived. And so there are two poles often in epistemology, at least modern philosophical epistemology. There's sort of empiricism, which you can kind of represent with John Locke, which is basically knowledge comes from experience and sense data. The mind begins as a blank slate and is just simply shaped by empirical sense experience. And then there's sort of a more innatism or structuralism pole of epistemology, that the mind is structured with innate concepts and learning is shaped by a priori cognitive frameworks. And these two poles of epistemology are often squared off against each other. But I think that this machine learning example illustrates something of a synthesis, that models combine predefined architectures, the structure, the Kant sort of thing, with data-driven parameter tuning, which is experience. And I think our brains are similar. We are both highly elastic, teachable, and adaptable creatures that are radically shaped by our upbringing and context. However, there are deep structures in the human mind that are shaped, enabled by this learning in the first place, and prepare us for the invariable challenges of life. This deep structure of our minds must also be deeply congruent with the deep structures of the grammar of reality itself in order for this to be true. All right, back to AI. One of the biggest findings in machine learning was the universal approximation theorem. And I think this is from like the late 90s and early 2000s. And it basically found that if you use a sufficiently wide and deep neural network, which is a machine learning or artificial intelligence algorithm, you can approximate any mathematical function. Therefore, neural networks can successfully approximate data generated by any function. And the statisticians who figured this out were George Cybenko and Kurt Hornik. It's kind of almost like an AI version of the form of forms. But all right, so I've taken my same data set, my same line that I fit earlier, and now I fit a green line in there in the middle that is from a neural network. And you can see that it fits the data pretty well, but kind of there in the middle, it takes like a dip down because there's sort of a little random blip down in the data that I generated. So this is an example of what's often called in statistics overfitting, where if you use sort of too elastic or too squishy or too flexible of a modeling technique, your model can over-represent the data without necessarily mimicking the true structure where it came from. But it can get even worse. All right, the left-hand side of this picture is the graph that I already showed you. What I did is that at first I generated data between values 0 and 10 on a line. And now I generated more data from values 10 to 20. Basically, I doubled the range out to the right. And what I then did is I had my line that I fit from earlier project further than it had been trained on. So both of these lines were only trained on data from 0 to 10. And so now I'm saying, guess what happens when we go out beyond 10, from 10 to 20? And the line, which is a very simple statistical technique, continues to fit the data very well. Whereas the neural network, it's sort of off and down below and does not fit the new data very well. This shows that a very flexible data modeling technique is not very good at extrapolating beyond the data that it has seen. It's very well conformed or mimicking of the data that it has seen, but it struggles with novelty because its flexibility does not really kind of comprehend or imitate the underlying data structure that generated the data. It just highly effectively approximates that. So neural networks are really only tend to be good with data, or good at solving tasks within the range of their training data, and they get really wonky once they go outside of it. So how do these large language models like ChatGPT and Gemini, etc., Grok on Twitter, how do these models work? Basically, you take a whole bunch of text, you transform the letters into number tokens. And what's kind of funny, this is similar to what you could call gematria, right? Gematria is a form of interpretation often associated with Judaism, where you take letters and you turn them into numbers, and then you use these numbers to kind of notice patterns in the biblical text. People often think that the number 666 in Revelation is actually supposed to be a gematria of Nero, Caesar, using Aramaic characters. So this idea of turning letters into numbers, that's how large language models work. They turn words and letters into numbers. And then you make an extremely large data set based off of whatever text you want to train it on. And then you train the model to predict the next token, the next numericized word or letter in the data set, and you train it over and over and over and over again, and you fit literally hundreds of billions of parameters. In that line example from earlier, I was fitting 3 parameters: slope, intercept, variance. When you're training a large language model, these are literally some of the largest models that have ever been created in human history, and they have hundreds of billions of parameters. I wouldn't be surprised if some of the newest experimental versions maybe even had cracked 1 trillion parameters. And so that's kind of how you make these things. But the model behind it is neural networks. The neural network is basically learning the mathematical relationships, the mathematical patterns in 100 billion dimension space that is fitting the relationship between these numericized words and what word comes after them. So it's a statistical approximation of the relationship between words and letters and characters. But like I said, neural networks can fit any mathematical relationship, or I should say they can approximate any mathematical relationship. So whatever the mathematical relationship is between the word microphone and race car, it can approximate that relationship. But it doesn't necessarily understand the true structure of that relationship. It's just a mathematical approximation. And so some of the things that we've learned from these LLMs is that while it's a universal approximator, it's not a universal comprehender. One might have hoped that the universal approximator would give LLMs superhuman intelligence, able to extrapolate knowledge into new horizons by virtue of the structure of being having been programmed into our language and then programmed into them. Instead, they can simply approximate the quality of language across vast domains of knowledge and use cases. Perhaps the over-reliance on neural networks traded flexibility for true comprehensibility, and universal approximation was traded at the expense of really being conformed to the true structure of language itself. While human brains are seemingly able to map the true forms of things in our mind, as Aristotle said, as Gregory of Nyssa said, large language models are like a pixelated version of this ability. The squishiness of the neural net structure exchanges adaptability and scale for true formal fidelity. It's like your favorite vinyl record being turned into an MP3 file or something like that. But maybe this is some fundamental difference in the architecture of our brains versus computers. Maybe if we got the right mathematical structure, we could train LLMs to work more like a human brain and less just like a statistical approximation of a human brain. Or perhaps it's the fact that we're compressing words into numbers that is the source of the problem. Perhaps language is just fundamentally more complicated than numbers. While you can approximate words with numbers, there is still something lost in the process, like going from analog to digital. Or perhaps the problem is that these LLMs simply lack a soul. So I want to talk a little bit about genetic optimization algorithms. So how do these statistical models train over 100 billion parameters? Well, it's actually not that complicated. You start with initial values for the parameters. You slightly tweak some of the parameters. You evaluate the objective function, which in a large language model's case is how well it can predict the next word in your data set. If the tweak to the parameters improved the performance of the LLM, then you keep the change. If it did not, then you discard the change and you repeat this and you repeat and repeat and repeat. And that's why it takes so much time, so many NVIDIA microchips, so much electricity, so many enormous data centers to make these things, because it's doing this over a hugely complicated problem space. So you can ask the for cause question about these LLMs. The material cause, what's the material cause of an LLM? Well, it's a microchip, some silicon, and some electricity. What's the efficient cause? Well, it's made by this step-by-step algorithm that I described. What's the formal cause? Well, you get the parameters plus the structure of the model. And what's the final cause? Well, it's trying to optimize the objective function, which in an LLM's case is approximating the next word. As Mary Harrington said, modern philosophy often assumes that material and efficient causes are sufficient to explain everything, but formal and final causes are essential to understand what's happening here. The final parameter values aren't written in the code. You can't find the parameter values in the code that generates the model. They are instead the result of the form-seeking discovery process working toward the goal of functional optimization. So I wanted to give an example of how these models work, because I swear this is actually really quite important for understanding Vervaeke and Pageau. I really think that this will help clarify some things. So up on top here, I made this thing where I can generate some random data about a line. And then what I do is I run one of those sort of genetic algorithms that's trying to reverse engineer the line. And the way that I do this is I've got 10 different versions of it running independently of each other. And basically, you can think of these as 10 form-finding functions that are trying to figure out the form of the line. And so I'll play the animation. In the top half of the thing, you should see lines that slowly work their way towards matching the shape of the line that you see on the screen. In the bottom half, that kind of red section, you'll see the green dots, which are the individual models. And they're trying to find the most likely place where that line is. And you can see I've got a sort of an X marks the spot on that red graph. And they're basically going to be sort of like blind drunken sailors, is how I think about it, slowly stumbling their way up the hill of likelihood to try and find the maximum likelihood at the top of the line. So, all right, let me play this and see if this works. Yeah, you see the lines, the dotted lines are slowly moving up, trying to match the true line. The green dots on the bottom, first they find the correct slope. They find the correct slope relatively quickly. It's mathematically easier to do that. It takes them a little bit of a while to figure out the true correct intercept. That's actually more mathematically difficult for the algorithm to figure out. But it keeps going. You can see more and more of them are getting close to the center of the cross check mark. And after something like 200 iterations of this algorithm, you can see that most of the green dots have found themselves pretty close to the right answer, and the black dashed lines in the upper part have converged to the real answer. And so you can see that this algorithm that doesn't know anything about the right answer other than that it should be a line is stumbling around trying to figure out the right value of the parameters that best optimizes the optimization function, and it's able to converge to the right answer. And that's, a simplification, but not that big of a simplification of how these large language models get trained and how lots of statistical models and AI models get trained. And the reason that those are called genetic algorithms is because they mimic the way that evolution works, right? You start with a set of answers in your DNA. Your DNA mutates a little bit from generation to generation. If that mutation causes you to survive better than your ancestors or your competitors, then good, those mutations will stick around. If it causes you to behave worse, then they won't stick around. So it's really very similar to the process of evolution, and they were actually kind of designed that way. And so that is, I think that you can then take that example and then flip it back around, and you can think of the process of evolution like Jonathan Pageau and Mary Harrington were talking about. It's sort of this form-finding function where it's trying to optimize the fitness of the organism to its environment and niche and purpose. And that the process of evolution is this optimization function, this form-finding possibility thing, where sort of the purposes are emanating from above and the possibilities are emerging from below. It's sort of like the material and efficient causes constrain and afford all the different possibilities of what an organism could look like biology, chemistry, and physics are like, here's all the things that an organism could look like. The efficient causes, oh, by the way, it'll need to reproduce, it'll need to live a life like this, it'll need to have this sort of metabolism, etc. So that sort of like shapes the possibility landscape. And the final cause is sort of like the purpose of an organism. And then the form is sort of like emergence of this algorithm seeking out the form that best accomplishes the purpose in its environment and under the constraints that it's in. And I think that that's really kind of an interesting way to look at evolution. I think that's something pretty similar to what Jonathan Pageau was talking about. All right, so I'm going to play a clip from a conversation I had with Jonathan Losos. He's an evolutionary biologist, formerly at Harvard. And so I was talking about his book, Improbable Destinies, which sort of argues that evolution has something of a destiny to it. All right, so I'm going to play this clip.
Well, it was met with excitement because, as you said, the idea of convergent evolution has been around for a long time, but until recently, it was still considered to be kind of remarkable that species in different environments, because they don't have to evolve the same way. And so the fact that they did was just seen, isn't this incredible? The power of natural selection to sculpt different species to be so similar. And so just single examples of convergence used to get a lot of attention when they were discovered. And so to say that we were having not a single case, but 6 different types living together, were all converging, the entire community was converging, that was sort of a higher level of convergence. And so people were very excited about it. In more recent years, we've seen that there are other examples of other sorts of organisms, but anoles were probably the first example to be worked out in really thorough detail, including evolutionary tree analysis and so on.
Mm-hmm. And I remember another detail in your book. As we continue to genetically sequence more and more animals, we've even discovered lots of things that we thought were all the same species as turning out to be very, very different from each other in terms of their family tree origin. But yet they can look so remarkably similar that they had flown under the radar as actually being the same species for a long time until this DNA analysis was done. Am I remembering that correctly as well?
Yes, you are. Just to give you one example, there is a type of sea snake. The sea snakes are snakes that live in the ocean basically their entire lives. There was one that was thought to be found throughout much of the world, from Australia to Asia and throughout the Indian Ocean and into the Pacific. And when people look at the DNA, they've found that their DNA of different populations of the species were very different. In fact, so different that the populations weren't even closely related to each other. And so it became clear that this very great similarity was the result of convergent evolution. And it turns out that was particularly important because these snakes are highly venomous, and their venoms were different, that their external appearance was very the same, but their venoms were not. And so understanding that these were not all the same thing actually had a lot of medical importance.
Yeah, so even and that's amazing that the similarity was even at the level of appearance, like coloration, stuff like that, which sometimes you might think, sea snakes, it's almost a little arbitrary. Maybe it has to do with sexual selection and some particular, history of their organism that they come to be colored the way they are. But even at the level of coloration, they were evolved from different types of snakes as their sort of parent or ancestral species and converged to look remarkably similar and to be highly venomous, although sometimes, like you said, the venom, the actual molecule of venom that they used might be different. But the idea that you need to be highly venomous was the same. So it's remarkable that it's almost like convergent evolution is becoming more and more the expected norm as opposed to a curious, example or something like
that. Well, that is absolutely true. And in recent years, there have been a number of people who have produced enormous books, some of them this thick, with just example after example of convergent evolution. And as I mentioned a moment ago, we used to think that convergent evolution was a remarkable but unusual event. And that's why every time a new case study was presented, people would get so excited. But what these compilations demonstrated is it's a lot more common than biologists appreciated, so much so that some people now consider it to be the expectation that if two species live in the same environment, they will adapt to it in the same way. Now, that might be taking it too far to the extreme, but we certainly recognize that convergent evolution is a lot more common than we used to appreciate.
Right. And it almost brings up the larger question of what exactly do we mean by species? And that we can be talking about species at the level of they all reproduce with each other, they have a shared genetic origin and stuff like that. But then there's almost like this extra word that we need, like fills the same type as, or is serving the same niche as this thing over here that we previously might have thought was the same species, but it turns out is a completely different kind of sea snake that just looks identical to the kind of sea snake across on the other side of the Indian Ocean. And it's almost like to even recognize convergent evolution, we need a new word in our vocabulary that's like, well, not species, but like ecological type or something along those lines.
You are correct. There are actually a bunch of terms that are used that are very technical ones. For the anoles, we call them ecomorphs, that a species that's adapted to a particular habitat with a particular particular anatomy, it's called a morph, is an ecomorph. And so there are these different ecomorphs on the different islands. Plant biologists often call them ecotypes. And there's a lot of jargon, as you know, in evolutionary biology. So there are some terms out there, but a nice, readily understood term would be useful.
Yeah. So another thing that was really so I thought that was interesting and relevant that in evolutionary biology, they're having to come up with something like almost like a Platonic ontology, where there are types of animals and then different evolutionary pathways might lead different organisms to converge on the same thing. In one of my first conversations with Vervaeke, I talked about how it seems like there's like the form of the polar bear in heaven. You can imagine a perfect polar bear who is perfectly optimized to do polar bear things. It's sort of like the perfect solution to the puzzle problem of how to fulfill the purpose of being, large carnivore that eats mammals and other large animals in the Arctic. You have to be big and survive winters, and you have to be able to hunt down your prey. You have to be able to reproduce and those sorts of things. Those are the constraints. Okay, there's the optimal solution to it. That's like the perfect polar bear who is in heaven, you could say. And the polar bears here on Earth are like various approximations of trying to embody that form, and evolution is always seeking out to try and find the little improvements here and there to come and arrive at that solution. And that evolutionary biology is full of repeated convergence on similar or almost even identical solutions, the same way that machine learning algorithm that I showed you, all the 10 dots were operating independently of each other, and they started at the same point. I could have had them start at different points, but they all converged at the answer or somewhere close enough to the right answer. And that evolutionary biology seems to behave the same way. Although I'll note that in evolutionary biology history, there's often what's called punctuated equilibrium, where things sort of stay the same for a while, and then there's a bunch of changes, and then things stay the same for a while, and then there's a bunch of changes. And to me, I think that there's like, when environments are stable, organisms often arrive near the correct answer pretty quickly, quicker than we might think, and then stay kind of with small changes around that answer for a long time. But a big change to the environment, a meteor crashing into Earth, some two continents colliding together and all the species intermixing with each other and competing with each other, various changes like that can disrupt the relationship that an organism has with the form that it's seeking to embody. And then it might have to seek after a new form, or the optimal solution to that form might change. And that's sort of how we see biology kind of behaving the way that it does. And then another thing I brought up with Vervaeke is that it's not just biology that does this. Biology is a unique and special and powerful example, but you'll often notice in nature that there are things that seem to resemble shapes. Like this is a picture of Mount Everest next to a picture of a tetrahedron. And that Mount Everest, you can imagine, if you want to be the biggest, best mountain you can, you need to be a very stable, rigid structure that's able to withstand erosion well. You need to be built out of something really tough and abundant like granite. And lo and behold, the biggest, tallest mountain in the world is almost perfectly a tetrahedron, which is a great shape for not eroding and for being very stable. And so it's not like Mount Everest consciously shaped itself into a tetrahedron, but of all the mountains that could have existed, the one that's the best at being a mountain is the shape that is almost a perfect Platonic solid. And I also sort of pointed out that planets do a very similar thing. Almost every planet that we know of is perfectly spherical, but that's because it kind of helps a planet to be spherical. The orbit is stable. Like all the stuff that's too far away from the middle falls down to the middle and kind of makes a spherical shape. So it's a very stable shape for a planet to be in. And lo and behold, almost every planet that we see is a sphere. And I kind of think that this is something like Plato's revenge. People talk about Aristotle's revenge, but I think that the emergence of Platonic solids is something like Plato's revenge. Plato had a book called the Timmaeus, which is Plato's account of the origin of the universe. It's sort of like a mixture of myth and metaphysics and proto-science. Neoplatonists have revered it almost like scripture for a long time. Modern readers, though, if you read it, often get bogged down in pages after pages of geometry and speculations about Platonic solids, like how fire must be made out of tiny tetrahedra. But he wasn't completely off track. The examples that we just explored show how Platonic solids still have a way of revealing themselves as part of the basic structural grammar of reality. So Plato was, I think, a little bit more right than sometimes we give him credit for nowadays. And then this quote from Gregory of Nyssa, I think, is particularly mind-blowing in a lot of ways. For this reason, the human being was fashioned last, after the plants and animals, nature advancing in a certain way sequentially to perfection. Thus, reasonably, nature makes the ascent, as it were, by steps. I mean, the properties of life from the lower to the perfect. And I just think how that's like the perfect description of organisms kind of moving up the hierarchy of being and becoming more and more perfect forms. And this wasn't said by an evolutionary biologist. It was said by a Christian theologian almost 16 or 1700 years ago, which is just remarkable. And so I'll try and do my best Jonathan Pageau impression. So here's a picture of Noah looking at the Ark. On the Ark are like the Platonic forms of all the animals, male and female, the archetypes of life preserved from extinction. You know, these are the forms that the animals here below are chasing after. The flood waters represent the destructive, judgmental, and chaotic forces of entropy that dissolve imperfection into disorder. But within the Ark, the patterns of creation are safe, held in sacred space beyond the reach of the chaos. The Ark was designed by God, but built by Noah, a symbol of how humans are God's sort of representative co-creators here on earth. When man listens to the voice of God, the deep logos behind all things, he becomes a steward of nature's forms. Man plays a role in the final form of nature, serving as God's obedient and creative representative to protect and caretake the pattern of creation. I think that's sort of an interesting way of thinking about Noah's Ark. So I'm going to play a clip from Jordan Peterson's conversation with Richard Dawkins.
Okay, so could you imagine a scenario where a meme had sufficient functional adaptive significance so that the individuals who acted it out gained a reproductive edge?
Yes.
Okay, so then you could imagine a situation where there was, I think I've got this right, a Baldwin effect between the meme and the genome.
Yes.
Okay, so then could you imagine an effect where the heroic hunters of the past who decided to cease acting like prey animals, maybe when they got rocks or sticks, were acting under the impulse that facing down the predator was the appropriate strategy? Because I was thinking about this reproductively. Like, you know that women are hypergamous. They like men cross-culturally about 4 years older than they are. The most fundamental female pornographic fantasy involves vampires, werewolves, pirates, surgeons, and billionaires. Dominant men who are capable of standing up to predators, who can be brought into an individual relationship. Okay, so that's the fundamental reproductive story meme that seems to drive women. It's allied with the hero myth. They're the different variants of the same story, the different sexual variants of the same story. And it seems to me it's not unreasonable to note that that's the fundamental story of humanity. And so I don't understand why you're not impressed by that.
We started talking about the Baldwin effect, and suddenly we got into women, what women like. I mean,
well, the men who act out the heroic meme are much more likely to reproduce.
It's an example, but perhaps we need to explain what the Baldwin effect is.
I was going to say that's probably helpful.
Yes, that would be useful.
Okay. It was suggested by Baldwin, I think in the late 19th century. It's a kind of genetic assimilation of a cultural or a learned idea. So the idea is that certain animals learn things, learn a clever trick. It might be nut cracking by chimpanzees, for example, or potato washing by Japanese macaques, or opening milk bottles by English tits. And it perhaps spread as mimetically as an epidemic of copying, and that's known to have happened with the blue tits and great tits in Britain. Now, certain individuals are likely to learn it faster than others, and there may be genetic variation in the speed with which they learn it. And as the generations go by, natural selection would have favored speed of learning the new trick. And eventually they would have learned the new trick so fast, they didn't need to learn it at all.
Right.
It becomes genetically assimilated into the genome. That's the Baldwin effect.
Okay, that I would say that's essentially the same pattern of archetype evolution that's implicit in the Jungian theoretical
Well, that's
model.
very interesting, because that suggests that Jungian archetypes might be genetically assimilated via the Baldwin effect.
Yes,
now, that's a fascinating idea.
Yes. Okay, so now
I know we're coming to the end of our time soon anyway. It's nice to end on a shared point of interest, which is the Baldwin effect and the archetype's potential origin in the Baldwin effect. Do you think that is something that is worth exploring further? Is that something that we can
crucial
that we can
I
test?
think it's interesting. Yes.
Well, it speaks of the potential relationship between the spread of memes and the alteration of the genetic process. I would say it probably happens fastest by sexual selection. So
yes,
right. So imagine that a meme. Okay, so imagine that a meme develops a representation, imaginal, and the people who embodied are more effective in dealing with predators. And then imagine that there's a concordance between that and the attractiveness of those males to women. Seems highly probable. Well, then you can see that because sexual selection is a pretty rapid mechanism, that Baldwin effect gets spinning
I totally agree with that.
rapidly.
I've even suggested, actually, a slightly way out suggestion, that the human habit of standing on our hind legs might have been sexually selected and then genetically assimilated via the Baldwin effect. Chimpanzees do sometimes walk on their hind legs. Now, if for mimetic reasons that was sexually attractive in our ancestors, so that it spread
issue?
as an epidemic of sexual display, then natural selection could have favored those individuals who were best at standing on their hind legs, genetically speaking, and then it would become genetically assimilated. This sexually selected mimetic effect could have been genetically assimilated and given rise to the genetic tendency to walk on our hind legs.
So I remember what I was going to ask you about this. So imagine you have a situation in the biblical narratives where the idea of sacrifice is dramatized and ritualized. So it's acted out. It's not exactly understood. It's dramatized and acted out. Well, I believe there's a concordance between the probability that sacrifice would be offered and the ability of someone to forego gratification or to work towards a future end. They're the same thing. And the ability to forego gratification, which is associated with cortical development, is a great predictor of future success. Let's say future, because we know, for example, that trait conscientiousness, which is something like the ability to delay gratification, is the best predictor that isn't cognitive of long-term future success. The ability to sacrifice the present for the future is a hallmark of a strategy of adaptation that's going to propagate down the generations.
That's interesting. As a Canadian, you probably know about the potlatch phenomenon.
Yes.
Where great sacrifice is a social display, destruction of one's own property which is a form of sacrifice. Mm-hmm. Destruction of one's own property is a mark of prestige.
Right. Well, it indicates in all those communities, it indicates two things: your willingness to distribute generously to the community because you're a big man if you can do that, but also your faith in the process by which that wealth was generated. I'm so good at, I think women use wealth as a marker of sexual attractiveness, not because they're interested in wealth, but because wealth is the best single predictor of the ability to generate wealth. And the potlatch is that kind of manifestation. It's like, yes, I have all this stuff. I can give it away and burn it, and I can make it again, because it isn't the wealth. It's the capacity to generate the wealth, right? It's a process or a spirit, you could say, if you wanted to get metaphorical about it. So there's this remarkable concordance between your work and these works that I've been investigating. Like I said, no one knows the two literatures. And so it's very frustrating in a sense, because I understood your concept of meme, I would say, in exactly the way that you just laid it out. And I thought, this is exactly what I've been studying. There's these fundamental narratives, and the people who embody them. Look, the heroes in the theater, they're actors of a narrative meme. They're obviously attractive. People flock to watch them. You know that if you take vervets and you show them pictures of the other vervets in their troops, they spontaneously gaze longer at the higher status vervets. Right, it's exact. So imagine this, in the human society, is that you have people who act out the appropriate meme, let's say, which is something like a meta strategy for dealing with predation. It's something like that. You can approximate that to a greater or lesser degree. The more you approximate that, the higher you are on the sexual selection, in the sexual selection hierarchy. And I think that's clear. Like, it's a bit more complicated than that, because women seem to be, the pornographic literature that women prefer is both the capacity to stand up against predation and maybe even to be a predator, but that has to be brought into alliance with the ability to make a intimate relationship and share. So it's like half monster, half cooperative distributor, cooperative generous distributor. It's something like that. You can see that's a real knife's edge evolutionarily, because you want someone who can keep the real monsters at bay. But if they're such a monster that they don't share and aren't generous and can't take care of their children, they're just another bloody predator.
So, Richard, the Baldwin effect applied not so much just to the mimetic preference for people who stand up, for example, but something like a dragon, the abstracted predator. Is there any kind of Baldwin effect implication of this kind of thing?
I think there could be. I mean, I think it's an interesting idea that Jungian archetypes could be Baldwinized memes.
Yeah, so I think that is something like an alternative proposal for the solution to Meno's paradox. How is it that we know enough about something to know what we're looking for, but not enough about it to know the full answer in and of itself? How did this knowledge get into our minds in the first place? The blank slate answer doesn't seem very satisfactory because it runs into Meno's paradox. But if these things are already in our minds, how did they get there? And that Jordan Peterson's answer is something like that the process of evolution through behavior and imitation and sexual selection has sort of brought these mimetic behaviors, images, symbols, stories, attractions, etc., into our own very makeup of our mental structures via this Baldwin effect. And that's sort of the bridge between Jordan Peterson and Richard Dawkins in this conversation. And, there's two other poles of epistemology, right? I sort of previously talked about the pole of kind of blank slateism versus innatism. There's two other poles that's like realism, which is, you could say Renes Descartes, the world exists independently and can be known by the mind in itself through reason and discovery. And then there's pragmatism. Oh, it still says Kant. That's supposed to say William James. So William James's pragmatism is something like, truth is what works. Knowledge is shaped by usefulness, goals, and function. Organisms are shaped for survival, not for truth seeking, right? This idea that truth is kind of relative and that truth is what works versus truth is kind of abstract and true in and of itself. And you can see another sort of synthesis of this with this, I guess you could call it Platonic Darwinism, is something like the fusion of Vervaeke, Pageau, Peterson, and Richard Dawkins. The successful persistence of being is a revelation of truth itself. The procedural, perspectival, participatory, and propositional all happening in relevance realization together. All right. But I haven't let Vervaeke speak yet, so I'm going to give a little bit of voice to Vervaeke because I think there are some disagreements or some pushbacks that Vervaeke would have on this framework. So this is from a conversation that I had with him, like, my goodness, how long ago was this? This was like 3.5 years ago. Wow. Anyway, so here is clip number 1.
That Jesus was enlightened, and this could explain a lot of his uniqueness, his specialness, if you want to put it this way, his ability to transform other lives, and he would therefore be in a category with people like the Buddha and like that, and he would be a fount of wisdom, and then the part of the proposal is that that doesn't require a supernaturalistic metaphysics ultimately in order to explain it. And and JP and Paul were very appreciative of that. They didn't. It was. I liked their reply in that they weren't denying that Jesus could properly be understood as enlightened, but they said that they thought there was something more, and the something more was the redemption of human history and the redemption of the physical cosmos, and that's what was carried in the incarnation. And then I responded to that by saying, but then what I should be able to see is good evidence for the redemption of history and the redemption of the physical universe. I'm just giving a little bit of context, and then this centered down on, well, how would you look at redemption? Is definitely a purposeful notion. You should see some sort of developmental line and progression that would be evidence of this unfolding. And so that's how it got to the discussion of whether or not there is purpose. And then I'll give me a couple more minutes,
sure.
Sam.
Yeah.
I'll say what my initial rejection was, or sorry, my original proposal, because it was more of a question, I think, in fairness to me, and then something important that I've taken up that was said by both Paul and JP in various ways. So the first thing I said was, you look out over history, and this is, you can see how both of these touch on the problem of you look over history, and you like the previous century, the 20th century is just a century of bloodshed and mayhem. And it's like this, and nothing wonderful seems to have resulted from it. It's hard to see a redemptive arc in history when you look at Auschwitz, is how I put it.
Right. And the 20th century seems uniquely weird in its bloodshed, and that. All right, moving forward to a different clip. Again, kind of further pushback from John on some of these ideas.
I think it has to be taken seriously. And then the other point is, when I look at the physical universe, it seems like 99.9% hostile to life. And even if you put all the planets together, they're a minuscule amount, and et cetera, et cetera. And then it seems plausible that there's been billions of years when there's no life at all. And it doesn't seem like the universe is here for life. Now, I bought a really good book. I haven't had a chance to read it, on the fine-tuning argument, and we could possibly talk about that. But it is reasonable to say that argument is very controversial right now.
Yeah, I don't. For the record, I don't even quite like it. All right, skipping ahead even further to let John continue to push back on some of this.
And this came up in the discussion when we start talking about like the fundamental grammar of reality. I think that I think of these things as precisely not being on purpose. And here's because and this is a sort of a Platonic argument about goodness and realness. Things the things that I value truth for its own sake, not just for its instrumental uses. I value beauty for its own sake. I value goodness for its own sake, precisely because these things are not for something else. They are for themselves. And I'm just making a gestural argument here. I can make it more complex, but all of those are together in the for itselfness of reality. And so I think of realness, especially when we get to these fundamental levels, as something that, because it's real, precisely because it's real, it ultimately is not instrumental in any way. Its existence is not instrumental. Its existence is inherent. And that means it has no purpose, especially if you acknowledge that it's not autopoietic at that fundamental level. So if it's neither autopoietic and it's not instrumental, I don't see how we could talk about it having a purpose. That's the core argument.
And I think, right. And one last clip from John.
When we are responsive and then responsible to the emergence into our life and consciousness of this aspect of reality, it will definitely make us more purposeful and purpose. I think that's right. I'm not challenging that. I guess for me, I would say I don't see there being any purpose to emergence and emanation. And I ultimately don't see there being any, it's the complete, Plotinus talks about it, just the self-overflowing of the one. It's just the plenitude of being. I don't know how else to, and for me, eternity is exactly the domain in which purpose makes no sense, because purpose is a temporal notion in some fundamental sense. And so I don't see, and again, I'm saying something very orthodox. God has no purpose. God can't possibly have a purpose.
Right.
So, and Spinoza makes that clear. It's like what would God be intending, right? What does that mean? That doesn't make any sense.
All right. So bringing this to a close, at least part one for now. While Vervaeke and Pageau clearly have many similarities and shared ideas, I think the fundamental differences between Pageau and Vervaeke is something like this. Pageau sees purpose, telos, and final cause filling up the entire hierarchy of beings and filling everything with meaning. Vervaeke is less willing to go there. He sees purpose as more locally placed and situated. For Vervaeke, over-attributing purpose language risks an instrumentalization of things that simply exist and are via the plenitude of being. The course of history, the laws of physics, the process of evolution are mischaracterized when described with the language of purpose. While this might seem nihilistic, Vervaeke will purpose back again the nihilism through reframing. If you think the heat death of the universe makes everything here and now meaningless and irrelevant, couldn't you say that with equal force that the heat death of the universe is irrelevant for your sense of meaning? Vervaeke, despite hesitancies with anthropocentrism, might actually have the more human-centered philosophy. It is humans with their unique self-awareness and need for wisdom, meaning, and purpose that is ultimately the best place, or perhaps the final place, for which teleological language is appropriately used. For Pageau, this is not enough. If there is purpose at one level of the hierarchy of being and purpose at the next level too, by inductive proof, purpose must go on from the bottom to the top of the chain. Humans, yes, but also groups, cities, angels, demons, gods, nations, stories, and the history of the universe are all shaped by purpose. And without this purpose, I think Pageau fears that Vervaeke's limitations on purpose will put limitations on meaning, and his attempt to fix the meaning crisis will fall short. Vervaeke's response might be something like, I hear what you're saying, but I fear if your search for meaning flies too close to the sun, you risk getting burnt. All right, this was part one of this series. I'm going to do a part two, which is going to delve more into angels, demons, gods, and the nature of spirit. I tried to cram it all into one video, but I just couldn't fit everything I wanted to say. So tune in next time. And again, this is preparation for a conversation for Pageau and Vervaeke to have on these subjects again. It's been a while since they've dealt with these questions on purpose, I should say. And hopefully that will be a teaser for the conference and help the conference itself be more productive when it comes. So thank you all for listening.